To this point, we've imagined routing as getting from one particular place to one other particular place that we know we need to be at. But sometimes, especially for a large and popular service like Google, there's not one good place if everyone had to go to the same place to deliver a message to Google. Some parts of the network are inevitably going to be closer than other parts, and these other parts might be very far away indeed. In which case, it might be worthwhile to replicate Google's service in different places and have packets intended for Google in one part of the network to go one way, and packets intended for Google in another part of the network to go to a closer host. This is possible through DNS if nodes in one part of a network are configured to ask a DNS server that will point them one way, and nodes in another part of the network are configured to ask a server that will point them in different ways. As we've seen, DNS can provide multiple answers anyway for an address, so it might as well provide an answer that sends you in the right direction. That is, these packets will actually be delivered to different IP addresses that can go in different directions. That's good as far as it goes when you have a name, like google.com. But what if you're trying to get names? That is, what if you're trying to talk to an DNS server? Google's 8888 DNS server is another popular service, and it would be again bad if all parts of the network had to send it to a machine in one particular spot in the network as opposed to another spot. We don't have the luxury of a name that we can point to different IP addresses to solve this problem. But what would prevent this autonomous system on the bottom left from claiming that it can reach 8888, and the one at the top left also claiming that it can reach 8888 very quickly? BGP messages establishing that routing could go out to different parts of the network, and then nodes in the middle here could decide, based on different reports they get, about which way will get them there fastest. This is allowed in the internet, and it's called IP Anycast. It only works in certain situations. In the case of DNS, we resolve a name to an address and consistently use that address for a whole communication. But here, a client doesn't have any control over when 888, especially in this middle region, might go to the left or might go to the upper right instead. And so IP Anycast is only going to work for DNS-like services, where it's one packet there and back, and not a connection and not a long-term communication between the services. And that's why DNS is in fact the main use of IP multicast. That explains why 8888 is a DNS server that can be used anywhere with decent performance, because it's not actually one machine despite being one IP address.